What's up everyone, Patrick here, welcome back. Moving on to the next example. So this is another one of those examples where we're going to be dealing with revenue maximization, and we've done examples like this, but when we were dealing with factored form, quadratics. And so in this video, we're still going to be working with the factored form, but we're also going to incorporate the vertex form to finding the maximum revenue and whatnot. And so you could see how you can go either path in order to solve these kinds of questions. And because in this section we're focusing on finding max mins, completing the square, we're going to incorporate that process into this same kind of question. So when I'm going through this, I'm assuming that you've watched those examples in previous sections for this particular kind of case, where we're selling something and then there's either an increase or decrease in price and then a respective increase or decrease in the quantity sold, and then we're maximizing the revenue. So in this particular case, we're told a painter currently sells 160 paintings at $6 each, and then we're told for every 25-cent decrease in price, 10 more paintings can be sold. And in part A, we have to find an expression for the revenue in factored form, standard form, and vertex form. For part B, we have to find what price should the painter charge to maximize revenue, and what is the max revenue. And then part D, what is the max profit if each painting costs $1.50 to make. So let's start off with part A. Let me erase these questions here to give me some room. Now, the first thing we're going to do is we're going to get the factored form. And usually with this kind of question, that's how you start it off. If you remember, let's do a quick review here. When we're talking about revenue, revenue is equal to what? Well, it's equal to the price per item that you're selling. In this case, it's going to be paintings, times the quantity or the number of items that are being sold. So currently, the painter sells 160 paintings at $6 each. So at $6, they're selling 160 paintings, right? So what is the current revenue over here? The current revenue is 6 times 160, which would give us 960. So let me actually write that over here. So the current revenue is equal to $960. And now we're told that for every 25-cent decrease in price, 10 more paintings can be sold. Meaning that if, for example, we decrease the price from $6 to $5.75, decrease the price by 25 cents, 10 more paintings will be sold. So instead of 160, 170 paintings will be sold. If we decrease the price another 25 cents, let's say to $5.50, then 10 more paintings will be sold, and it will be 180. And so all of these are going to give us different revenues. We have to find the combination that is going to maximize the revenue. And so how can we do that? Well, we're not going to keep writing all of these out and then testing it out. That would take us a long time. So the best thing to do is to introduce a variable and create a revenue function. So let's introduce some variables. I'm going to let R equal the revenue. That's going to be the dependent variable. And then I'm going to let X equal the number of 25-cent decreases in price. Okay, so if the X value is 1, we're decreasing the price by 25 cents. If the X value is 2, we're decreasing the price by 50 cents. If the X value is 3, we're decreasing it by 75 cents. And so if X is the number of 25-cent decreases in price, how can we create a function here? Well, what we can do is we can say, okay, we're starting at $6, and then for every number of 25-cent decreases in price, then we're going to have 10 more paintings sold. Okay, so again, notice when x is equal to 1, we're going to end up with this bracket. The price bracket is going to be 575. And then if we plug in 1 over here, we'd end up with 170, which is the brackets that we had listed before when we just did it intuitively. Now I'm showing you how it's going to relate to the equation. If x is 2, meaning there's going to be 2 25-cent decreases in price. If we plug in 2 over here, 6 minus 0.25 times 2, which is like 6 minus 50 cents. So if the price is 5.50, then if we plug in that same 2 over here, 10 times 2 is 20, 160 plus 20 gives us 180, etc., etc. So now instead of listing them out, we made it into a nice revenue equation that we can work with. And now because we have a general variable, we can work with this. This is going to end up being a quadratic when we expand it. We can work with that quadratic and see where that vertex is going to be. And so this actually, answers part of the question for us, because this is the factored form for the revenue. So we got 6 minus 0.25x, and then we got 160 plus 10x. And this is the format that we were dealing with in previous videos. And so from here, if you remember in those previous videos, we would find the intercepts from here because it's in factored form. And then we had the intercepts, and we were able to find the midpoint of the intercepts, which would give us the x value of the vertex. And we plugged in x value here to find the maximum revenue. That was the process. And I'm actually going to do that process as well, but more so at the end to confirm that we get the same vertex when we do it with completing the square. So it's nice because if you are going to complete the square on this kind of question, there's also a way to check that you're getting that correct vertex by finding the intercepts over here, the way that we did it in the previous examples in those factored form sections. Okay, so this here, it's the factored form for the revenue. Now they also want the standard form. Well, standard form, pretty simple. All we do is we expand everything. So we would just multiply everything out. So we'd have 6 times 160, which would give us 960. Then we'll have 6 times 10x, which would give us 60x. Negative 0.25x times 160 would give us negative 40x. And then negative 0.25x times 10x would give us negative 2.5x squared, like that. And then let's rearrange this to be in proper order. So this would go in front, negative 2.5x squared. These are like terms. Those are just going to simplify to 20x. And then we got the 960 at the end there. Okay, so this answers the other part for part A. This here is the standard form. So we have a factored form quadratic. Now we have a standard form quadratic. And then from here, let me actually write it up here just to give myself some room. So we got r equals negative 2.5x squared plus 20x plus 960. And now that we have the standard form, what we can do is complete the square on it in order to get that third format, the vertex form. And so to complete the square, what we would do is first factor out this negative 2.5 from the first two terms. So we'd end up with x squared. Now 20 divided by negative 2.5, if you do that in your calculator, you'd end up with negative 8. So we'd have negative 8x over here. And then we got the plus 960 on the end. And then what do? We take that negative 8, we divide it by 2, and then we square it. So that would be negative 4 to the power 2, which would give us 16. So we end up with negative 2.5 x squared minus 8x plus 16 minus 16 plus 960, like that. Then take out the negative 16, so we got to multiply it by what's in front, multiply it by the negative 2.5. Negative 2.5 times negative 16 would give us positive 40. So we end up with negative 2.5 still in front. Then we got the x squared minus 8x plus 16. This times that would give us 40. And then we got the 960 like that. And then remember this now, it's always going to be a perfect square trinomial. And so that's going to end up factoring into x minus 4 squared, and then 40 plus 960 would give us 1,000. And so this ends up being the vertex form for that same revenue function. So let me actually write it up here. So we got r equals negative 2.5 x minus 4 squared plus 1,000. So all three of these, they're the exact same revenue function. They're the exact same quadratic. If you took all of these and then graphed it in Desmos, you would see just an overlapping quadratic. All three of them are the same: factored form, standard form, vertex form. Okay, and this is what's new in this particular question versus these kinds of questions that we did before, is we weren't really getting this vertex form. But it's nice to get because we're able to get the vertex, which we could tell the vertex from the vertex form. It is 4 and 1,000. And we know, because the a value is negative, we know that this quadratic is opening down. And so the vertex that we get, we know that it's a maximum point. And that makes sense because we're maximizing the revenue. So this here, this vertex, ends up being a max point. And so what's nice is that the fact that we have this format, the fact that we have this vertex, that actually answers part B for us. Because we could tell in part B, from here, just from this vertex, we could tell that the max revenue, what's the max revenue? Well, it's this $1,000. And then they're also asking, what is the price that maximizes the revenue? Well, what we can do is we know that the maximum revenue is happening when x is equal to 4. But what is x? Remember, x is the number of 25-cent decreases in price. And so how many times did we decrease the price by 25 cents? 4 times, meaning that the price went from $6 to $5. Okay, so what I'm going to do, I'm actually going to erase these over here. I don't think we will need them for the rest of the question. We got the most important thing, the vertex. Now, to get the maximum or the price that maximizes the revenue, you got to take that x equals 4 and plug it into the price bracket. So the price is going to be 6 minus 0.25 times 4, which is 6 minus $1, which is $5. So that's the price that maximizes the revenue. That's going to be the price per painting. They didn't ask for this, but we can also get the quantity sold that maximizes the revenue. We would plug in 4 over here. So it would be 160 plus 10 times 4, which would give us, this would be 40. 160 plus 40 would give us 200. And notice that when we multiply these, 5 times 200, what do we get? We get the 1,000, that maximum revenue, right? So this is actually a nice way to also check your answer, making sure that this x value for the vertex that you get, once you plug it into the price bracket and the quantity bracket, that you get that price and that quantity, and then when you multiply them, you indeed get that maximum revenue. Okay, so the price that is going to maximize the revenue is going to be $5. The quantity that maximizes the revenue, or this shouldn't be, sorry, I shouldn't have put $1 here. This is just 200 paintings, right? This is not money. It's the number of paintings sold. My bad, I didn't catch that. Right? So the quantity, the number of paintings sold that maximizes the revenue would be 200. Right? So 5 times 200, giving us that max revenue of 1,000. Now, what if we want to do it what if we were finding this vertex, let's say we didn't complete the square, we wanted to do it the way that we did it before. meaning that we find the intercepts from here. How do we find the intercepts? Well, we find out what x values would make each of these brackets 0. And so here we'd have 6 equals 0.25x. So we'd have x equals, divide both sides by 0.25, it would be 24, positive 24. And then over here, when is this going to equal 0? That's going to happen, let's actually keep the 10x on this side, negative 160. X is going to be negative 60, like that. So those are the two intercepts for this quadratic. And so if we take those two intercepts and we graph the quadratic, so we got the revenue as the dependent variable, then we have x over here. Remember, x represents the number of 25-cent decreases in price. Then we got the revenue. So the two intercepts are going to be, it was negative 16 and then positive 24. And then this quadratic is opening down. So the quadratic is going to end up looking something like that, approximately. Not the most symmetric drawing, but it's going to look like that. And so how can we find this vertex using these intercepts? Well, we could find the x value of the vertex by adding the intercepts, dividing by 2. Remember, it's always good, that axis of symmetry is always going to be between the intercepts. So the x value of the vertex, or the axis of symmetry, is going to be negative 16 plus 24 divided by 2, which would give us 8 over 2, which indeed gives us 4, which is what we got from the vertex form. And then plugging in 4 into the revenue equation that we got, we end up with 5 times 200, which indeed gives us 1,000. So even if you didn't complete the square, even if you went about it the way that we were doing before, with the intercepts, then finding the midpoint of the intercepts, then finding the vertex like that, you still end up with that same vertex. So again, if you do have time on a test, it's a nice way to check your answer to make sure that everything is making sense. And then another important point, they didn't really ask anything about it in this question, but if you remember this point here, this point represents the current revenue because that's an x value of 0, meaning that we're not decreasing the price at all. And if x is 0, these two expressions go to 0 and we just end up with 6 times 160, and we know that that's equal to 960. Right? So this, for this kind of question, this point is always going to represent the current revenue when x is 0, when we're not going to be decreasing the price at all. And then it gets to a point where we decrease the price 1 time, 2 times, 3 times, and then the 4th time it reaches this maximum point. And then after, if we keep decreasing the price after, then the revenue is going to start coming back down, right? So the revenue is maximized over here when we decrease the price 4 times, or when we decrease the price by $1. And then finally, part C. Part C is going to be kind of tricky. It's going to be a lot of work. They're asking for a maximum profit, not a maximum revenue. So let's do a quick general, am I going to need this? No, I'm not going to need this because this is for the revenue. Okay, but I will need this over here, so I'm going to keep it. So just a quick review. So revenue, it's equal to the price per item times the number of items. But now we're told that the cost of each item is $1.50. And so when we incorporate cost, now we're going to be looking at profit. And just as a review, in case you do run into a question like this, profit, it's equal to the revenue that you generate, how much you sold, minus the cost. Okay, so revenue and profit are different. Here, in the first part of the question, the part that we just went over, this equation just dealt with this portion over here. But now we're going to be incorporating a cost portion, and we're going to be looking at profit. And to further generalize this, so we know revenue, it's equal to the price per item times the number of items sold. So what's the total cost going to be? Well, the total cost is going to be the cost per item, which we're given, it's 150, times the number of items. Right? So if we're selling 160 paintings for $6 each, 6 times 160, minus what's the cost going to be? Well, each painting costs 150 and we're selling 160 of them. And so that's going to give us a certain profit. So just in general, that's what profit is, if you want to make a note of that for any future questions. And so now we got to make an equation for the profit, and then from that equation we have to find the maximum profit. And so what we can do, I'll make the equation just right here. You know what, I'll do it up here. Let me just erase all this. So the profit, let's introduce a new variable, P. So let's write that. P is equal to the profit, and I don't think we need any more variables. We'll still be using that X variable. So the profit is the revenue, which we already had an equation for. So that's 6 minus 0.25x, 160, plus 10x. That's the revenue, that's these two brackets, minus what's the cost going to be? The cost per painting is going to be 150. And then the number of paintings, well, it's going to be the same as this bracket. This is the quantity bracket. So if we're selling this many paintings, well, we're going to also have a cost for that many paintings, right? And the cost per painting is 150, so we multiply it by that value right there. Right, so coming up with this is the toughest part, right? Because once we have this, then everything else is easy, because then you could just forget about the word problem even, and then you could just look at this as just a straight quadratic. We're going to have to expand everything, get it in standard form, then get the vertex form by completing the square. But it's more so making sense of this formula or equation for the profit, incorporating it into the problem, making sure everything makes sense, and then from here it's just straight algebra. So this here is the profit function, and so from here what we got to do is we need to get the standard form, so we're going to have to expand everything, simplify it, and once we have the standard form we can complete the square on that to get the vertex, and then we'll get the maximum profit. And then we'll also get the X value that maximizes the profit. It's actually going to be a different X value that maximizes the revenue. Okay, maximizing revenue and maximizing profit, those are two different things, because now we're adding this new dimension to the problem where we're incorporating the costs. So different ways to do it. You can expand everything from here. Another thing you could do, this is not always going to happen, but you can notice that you're actually dealing with the same bracket there, so you could factor out that bracket and then simplify these. But you know what, let me just expand everything. So when we expanded these two brackets multiplied, we got what, negative 2.5x squared, what was it, plus 20x, right, plus 960. I think that's what it was. Give me a sec. Yes, that looks right to me. So those two brackets multiplied, expanded to this, and then we got the negative 150, we just distribute into that bracket. So negative 150 times 160 would give us negative 240. And then negative 150 times 10x would give us negative 15x, like that. Okay, and then from there, we can simplify the like terms. So there's no other term that has an x squared, so this negative 2.5x squared is going to stay. Then we got 20x, 15x, that simplifies to 5x. And then we got 960 minus 240, which would give us 720, like that. So this ends up being our profit equation in standard form. Okay, so it's different, again, than the revenue equation that we had before. Now, if you were to do it the factoring way, what you could do is you could recognize that you could take out that 160 plus 10x from both of these, take that out, and then you'd have 6 minus 0.25x minus the 150 over here. And then inside the bracket, this simplifies. So you'd end up with 450. Yeah, 4.5 minus 0.25 x, like that. And then when you take this, expand it, simplify all of the like terms, you'd end up with that same standard form profit equation. And so from here, we need to find the max profit. So what we can do is we could just complete the square on that, right? Take that profit in standard form, complete the square. It's going to be in vertex form. Then we get our vertex, and that's going to give us our maximum profit. That y value of the vertex in this particular word problem is going to give us the maximum profit. So what we do, same process, negative 2.5, we factor out from these two, so we'd end up with x squared minus 2x, right? 5 divided by negative 2.5 will give us negative 2. Then we got the plus 720 on the end. Then the negative 2, we divide by 2, square it. That would be negative 1 squared, which will give us 1. So we end up with negative 2.5 x squared minus 2x plus 1 minus 1. Then we got the plus 720. Then we take the negative 1 out. We've got to multiply it by the negative 2.5 that's in front. So negative 2.5 x squared minus 2x plus 1 plus 2.5 plus 720, like that, right? And so from here, this always going to be a perfect square trinomial. So let's actually write it up here. The next line, so the profit is going to be negative 2.5. It's always going to be x. Half of that, half of negative 2 is negative 1. So we'd end up with minus 1 squared plus, and then these two added, it's going to be 722.5, like that. And so this ends up being the same profit quadratic, but in vertex form. This and this, they're the exact same thing. But now, because it's in vertex form, well, we're able to get the vertex. 722.5, like that. And that's what we're looking for. That's the maximum profit. So that ends up being just the answer to the question. So the maximum, and we also know it's a maximum because we have a negative a value. So again, it's going to be a quadratic that opens up. So the vertex we get is a maximum point. So the maximum profit is going to equal 7.2250, like that. Now, when is the maximum profit going to happen? Well, when x is 1, meaning if we decrease the price by only 25 cents. So notice that revenue was maximized when x was 4, but profit is maximized when x is 1. So that's what I said before. Profit, revenue, they're totally different. Once you incorporate this cost over here, that's changing dynamically by this x value. This quantity here is changing dynamically, and so it does change pretty much everything. That's why we got a different x value. Okay, so maximizing profit happens when we only decrease the price by 25 cents. And if we decrease the price by only 25 cents, if x is 1, what's the quantity sold going to be? It's going to be 170. We're only going to sell 10 more paintings. Okay, so like if you wanted to break it fully down, the profit is going to be maximized when we sell each painting for $5.75. And if we do sell each painting for $5.75, we're going to sell 170 paintings. And then each of those paintings that we sell, 170, is going to cost us $1.50. And when you do this algebra here, you'd end up getting that profit right there of $7.22 and 50 cents. All right, so just be careful with these kinds of questions. Usually these kinds of questions, for the most part, they're dealing with revenue, but I have seen them add a certain cost and then you're dealing with profit, and then it changes the game totally. So I did want to add that last question in case you do run into a question like this where they're asking you to work with profit instead of revenue. So just be on the lookout for that.